The story that has led me to this stage started during a Yocto project patch review. There was a patch proposing to update a crypto library that has just released a new minor version. The thing is that there were no vulnerability fixes in this update. So there was a discussion if we grab that update or not. And I had a look at the commits in the source repo. First commit, oh. Second commit, oh. Third commit, oh, we are going to grab it. That looks like CV materials. And I was right. A few days later, the CVs have been published. And what looked the day of the release as a simple bug fix was, in fact, a security release. So that made me think, how many people do actually depend only on vulnerability reports to update their dependencies? And this story will have a few main themes. Like the automation, and not only we, the attackers also, we can process hundreds of repositories per hour. There's AI that's showing up, and we can use AI to help the processing. And there's metadata, because your Git repositories contain more information than you think. So what is there in a Git repository? At the surface, you have the code, and you have metadata. The code is your source files, your build script, your documentation, your CI scripts, and there's also the metadata. The authors and the team size, you can deduct how many people are actually contributing to that project. You can also find out the decision tree, because someone commits a change, but also someone merged that change, someone approved that change, so you can get the power diagram of the repo. You have dates of everything that happened. You have branch names that sometimes hint of certain things, and you have also tag names that also sometimes get hints. And at the surface. An attacker will see a little bit more than that, because the source files contain sometimes funny things like API keys, passwords, and such. The build scripts may have a build machine configuration and maybe even access hints on how to get to that machine. And we are doing open source, so all the vulnerabilities are actually there. You just need to know how to look for them. Then, if you want to do social engineering, you have the authors, and you may get to them. And sometimes there are branch names that offer a little bit too much of information, like urgent security fix. Now, it's not an invented example. So attackers can't find things in Git repos. Now, if we look into the committee, you also can see more information that you typically see in a simple Git log. For example, here with Git log pretty fuller, I can see a little bit more than I usually do, because there is the author date. It's showing when the author of the patch has actually committed it. This date survives cherry picks, rebases, and all those things. And there is the commit date, which shows at what moment this commit appeared in this branch. And what we can see in this commit in the Linux Canvas table 616 branch is that between the moment that the original author wrote the commit and the moment Greg pushed it to the stable branch, there were more than 2 weeks. And, well, there's an memory allocation issue, so it automatically qualifies as a possible security problem. So between the fix itself and the moment it landed in stable, there were more than 2 weeks. And when we are at this, can you actually remove a commit from a repo that you have made public? I'm not talking about your personal repo that is only on your laptop, right? We are talking about a public repo. So if you are self-hosting your Git, then it's maybe. But what you need to do is you need to remove the commit from all of your branches. You need to rebase, force push, and so on. Then push the removal of the remote branches. Tell everyone else to do exactly the same. Theoretically possible, practically a little less. So for all of your keys, passwords, and other things committed by accident, it's going to haunt you for the rest of your life. Especially that when you have done it on GitHub, it's really there, and it's going to stay. That is a rediscovery of an issue that already has been reported, that you can access commits in deleted or private GitHub repos that have access to a public, that have at least one public fork. And in fact, GitHub says that in the documentation, that may remove things if it's really sensitive, otherwise change your keys. So going back to my Git commits and the security stuff. What if I correlated Git repos with vulnerabilities and CVEs? And then some of you were, Marta, but what, CV, what's that? OK. CVE means common vulnerability. Enumeration is the biggest database of vulnerabilities out there. Most people have been using it after it has been put into the NVD database. And there's a long story that because of NVD problems from 2024, the CVE program has started very strongly encourage metadata directly in the CVE entries. And it shows. There's way more. If you want to have a longer version of the story, I've done like 20 minutes of that in one presentation. And I've also done slow reading of the whole CVE entry for the Yocto project if you're interested. The same method will work the same for any other database. So OSV or the European Vulnerability Database works exactly the same way. So let's take an example. Traffic HTTP reverse proxy, CV 2025-47952. There is a Git repository, CVV5, where you can find JSON files for every single vulnerability out there. And you start looking into the given file, and you can see the title of the vulnerability. If you scroll below, you get to the references section, and quite handy, they are references to commits. So I have a reference to commits. I go there, and I end up in a commit in that traffic HTTP reverse proxy. Normalize the request path. That matches the description, right? Kind of. So I can have a look at what it contains. And this one, fortunately, has nice documentation that it's adding because it's changing the way it is parsing some of the special characters of URLs. So definitely, it is a security thing. And now, taking all that together, I can reconstruct the timeline of this CVE just using public data. The commit has been created on May 23rd. And the commit and auto date are the same for this one. The fix release containing this one has been done on May 27th, and there was a stable version update on the same day. This information I got from the tag information. Then, GitHub Security Advisory gets live on the 28th, and the CVE entry is published on May 1st. And that's the moment when your security scanners start picking it up, when they get the metadata. There are a few things of the whole security story of this vulnerability that I do not have directly in there. I do not know the report date. I do not know when the team of this project learned about the vulnerability, and that could have been weeks or months before. And I also do not know one critical information. When did the developer push the fix to a publicly available repository? Because I have the commit date. It was in some branch, but it could have been on their laptop. So this is one piece of information I'm missing here. So I have a look at the history. And in the history, I see that on May 23rd, there was a merge of the stable version to the new feature version. And there are some other commits that reference things like the root CA, what is raising a bell for security people because that's related to certificates, and fix panic at the beginning of the commit. That looks also somewhat interesting. So I would assume that it has been pushed on May 23rd. And I could have written a tool that is monitoring Git repos from now on, and it's getting me that actual information. So, to sum up this part, I can reconstruct the timeline of a CV. And in this case, it was likely a week before the fix has been published and the CV appeared. And that's a week that someone who was monitoring this repo could have used to actually launch attacks. A week is a long time. So, and if I wanted to do that kind of analysis at the scale, what could I do? And in fact, we did that, and we did more than that. This is a part of a longer work that we done with a team of Jean, Paul, Sandrine, Dimitri. And I'm just presenting small parts of the data analysis, working on a bigger white paper. I don't know how many pages it's going to be. We used the CV database as of July this year, and we have selected Git repos of 1,500 projects also during the same time, all that had GitHub commits referenced in the CV entries. Of course, I'm not going to list you 500 projects. Some of the important ones in the dataset are OpenSSL, Electron, Grafana, Ansible, FastAPI, Cilium, Minio, Redis, Kcloud, Ceph, and TensorFlow. So not the small things. And explicitly, I excluded the Linux kernel from the run because otherwise it would have been taken over the dataset. But this is a part file with the analysis. And then off topic, you have maybe heard about web scraping by AI companies, that they are accessing web interfaces of open source projects to bring Git commits, and those web interfaces are definitely not designed for bulk access, and there was news coverage on this subject. We do not do that, so that's not us. What we do is we do clone Git Repos, and then we do our processing on our servers. That's way more efficient for the way we do. And if you do massive data analysis like that, please do not use the web interfaces of open source projects. That doesn't make any sense. Back to our data. So, what do we have? The number of projects that we have, 1,500. Number of vulnerabilities, 3,778. In that set, there are 70 vulnerabilities that have CVEs, so the vulnerability information, published before the commit of the fix. Verified, most of them is just hours before, so that means that simply people were doing things in parallel and they pushed the information of the vulnerability just before committing the fix. But then it gets more interesting. For CVEs that have been published after the commit, the average number of days from the commit to the CVE entry is nearly 6 months. But it means that but we have a very, very, very long tail, because the median is only 10 days. So let's have a look at the histogram. So what we have is the most frequent case is that the commit and the CVE come out the same day, or less than 24 hours from one to the other. And then we have other buckets from 1 to 3, 3 to 7, and so on, that are roughly similar. Take a note that the typical security policy projects have is that they aim at releasing vulnerability either 30 or 90 days at least after the report. And this is from the commit to the vulnerability. The report was even before. So all those people telling us that that is a typical industry practice, that we actually release the fixes in less than 90 days, well, and yeah, that's covering all of the entries that were there. But we can maybe see something more. I also took entries of projects that had at least 3 CVEs. Because maybe for small projects that have a CVE every 5 years, that could take time for them to actually do the whole process. So I also filtered out projects that in the data set that we have had at least 3 CVEs. And the diagram basically looks very similar. And for the NUSCAN, it also looks very similar. So, and there are other things also in the data set. I want to have time for questions, so I couldn't put that much presentation of actual data in it. We have things like commits solving dozens of CVEs all together. Those are typically code dumps. It's clearly inside the company they had multiple commits, but then they squashed it all together and committed everything at once. There's sometimes complex fixes also, but most of that is commit squashing. We've also seen branches and commits with security references and CV numbers before the actual CV is published. Both of them. We've been investigating the cases of fixes years later than the CVE, and those are really real fun. And we have developed a project dedicated tooling to manage to synchronize also the release date. It turns out that getting a release date and which commit it is in which release is not that trivial, because projects have different branching methods. And getting to the closest stack is not as trivial as just running one Git command. Sometimes it's way more complicated. So, me as a security researcher, how can I know about the security issue before it actually gets public if I'm taking a look at your Git repo? There are a few very, very clear indicators. Stable branches are quite often very, very, very silent for a very, very long time. And then they can start getting fixes. And that means that there is a security release coming in most cases. There's also security-related language in many commits, sometimes even security fix or vulnerability before actual release. But a language also like crash, fix, validation, dereference, and all those things. And everything related to certificates or keys that make the security researcher wonder what's going on. As I said already, there are also CV numbers, also before being actually published. And the situation where a very complex fix gets merged rapidly, that's also a clear indicator that something's going on. And if I, as a human, can figure it out, what about AI analysis? In fact, that has been published last week. I couldn't verify the source code of those guys. They have managed to generate proof of concept exploits by scanning CV entries, so basically doing the same thing I do. Take the commit, analyze it, generate an exploit, and they didn't launch them. Who wants to bet if there aren't any people doing that with the launch phrase those days? So what can you do? And there are two different paths that you have. When you are the upstream, the first thing is to release frequently, then be able to release frequently. Some people still in 2025 think that just releasing a patch is enough as a fix. I do not agree. How many of you have recently recompiled Python dependencies that you used for a security fix? One person. How many of you know how to do it? Some of you know how to do it. But, well, most of people just use a package manager and they are waiting for a release to come to do the update, right? So the project also benefits from having a robust CI when they actually can test frequently, so that they can get their releases frequently. I would also recommend you to prepare the advisory at the same time at the fix and have them handy at the same moment, especially writing down if there are workarounds possible for the issue and how serious it is. So when you publish, people can actually analyze without analyzing the source code of the fix to figure out if it's important for them or not. And then the next one is one I'm guilty myself, depending on obfuscation. I've been telling people to write non-obvious, innocent commit messages to gain a little bit of time during the publication. The problem is that my current analytic self has sometimes problems finding out the right commit in the commit history in such a situation. The automatic tool probably can, but it's just frustrating, loses time, and doesn't allow to, for example, figure out if the issue that we see is the same thing as like the one that has been seen before. And please, please, for the vulnerabilities that you release, add the commit information, because for the analysts, it's really important to have. And if you will be forced one day to analyze old CVEs from 5 years ago or 20 years ago, that you have no hint what the actual date of the fix was, and you need to figure out if it still applies, that's a really fun exercise. And for high-risk vulnerabilities, when you know that it actually could be exploited, test on dedicated infrastructure and then push just before the release. Sometimes it's worth it. And if you are downstream, if you are using open source code in your products, so I would bet that's kind of everyone does, that's not going to be popular. But I tell you, update your dependencies when they release a bug fix. Waiting for the CVEs to show up, it's outdated. That brings you on risk. Just update. But for this to work, you need to have dependencies that can release frequently and rapidly, and they keep the API stable so they do not break your code. So do your homework. And that's the end. Or maybe rather, we are going to talk about this subject a few times in the future, I think. But at this moment, we'll have still a few minutes for questions. If I can see people in there. Yes, please. Okay, could you please speak loudly, because I may not be able to hear you.
Okay, that means if we are not publishing which one is the commit fixing the issue, that would leave all the consumers that rely on the building life patches, they're all unable to identify which one is the fix for that CVE, right?
It's not. The question was, if you do not publish the information of the vulnerabilities, would it be impossible to figure out which fix is for which? It doesn't mean it's not possible to do. It's just harder. For the bad guys, it just means that they need to run the tooling to generate exploits on every single commit. OK. In this research paper, they were taking like a few minutes per commit. Even for the Linux kernel, that's OK, if you have a powerful machine. It's making life way harder for everyone who is using your software and wants to analyze if that specific vulnerability applies to them, because typically your advisory won't contain all of the information and not necessarily cover the specific use cases that people have. So they won't be able to respond. It may happen, for example, in a case that you are raising a partial fix, that you have difficulties to completely fix an issue. You are raising a partial fix. And, for example, for some devices, you also need to block something through a firewall, for example. In this case, people need information to actually know which situation they are. Security through obscurity, especially in the case of automation, it doesn't work anymore. It stops analytics, and unfortunately, it stops most frequently people who want to help security. Because they typically do not have time to play with those AI tools to do that. So that's my answer. Next question. Yeah?
Did you use any automation for this, or did you do this all manually? For connecting the commits with the actual reports?
The question is if there's a tooling for the connection between the commits and CVs. We wrote the code on our own, but it's pretty simple because the CV entries are JSON, and they are really good tools those days to parse Git commits. So it's really simple to write. We plan to release this tooling, but it's a part of a bigger thing, so it hasn't been done yet. Next question.
Okay, so I have a question. So because you said that this is a part of a white paper you are creating right now, as a result of this white paper, will be some kind of guidelines for the contributors or creators of open source projects, so they can have some help to create more safer commits and general projects.
So the question was, in the bigger white paper that we are working on, will there be guidelines for open source developers on how to well handle that process? Definitely. And if we can get reviewers for that part, if it's clear enough, that would be absolutely great. Every time I'm working on this white paper, it's getting just longer. Next question. Yeah?
So what are your plans for the Linux kernel?
The question was, what are my plans on the Linux kernel? In the white paper, there will be the similar results for the Linux kernel. They are just not very interesting because they are very similar. The updates come in batches. And for the Linux kernel, we have code also that synchronizes the releases with the stable branches and different backports. So that's also interesting, but not much surprising if you had a look at that example with 2 weeks something between the commit and release. You won't be surprised. Yes?
So if you look at fixes for, say, the Linux kernel, you find many of them are for bugs that are 10, 20 years old. How relevant is much of this if the bad guys have tools that are going to go and just find those bugs ahead of any fixes?
The question was the bugs that those commits are fixing are quite often years old, so the bad guys could have found them earlier. And this is an excellent question because it's quite likely that some of them, they are known to bad guys. There's the whole market of 0 days when people actually say and buy information on vulnerabilities and the way to exploit them. And unfortunately, nation states create stocks of those. There were long stories related to leaks of parts of such databases. So, yes, the bad guys may know those things. That's why I have two recommendations. Be nice to security testers who actually report security vulnerabilities to open source projects instead of selling them in the dark web. And then secondly, fix stuff and take as little time in the whole bureaucracy of working on CVEs. Because it's not adding value, fixing the issues is adding value. I see a lot of work happening those days because of CRA or other things on handling vulnerabilities in the Linux kernel, in vendor branches, to make sure that things do not apply to your specific configuration. Why that time could have been used to actually fix some of actual issues. That's quite sad. In my personal opinion, with the speed of automation that we have, we are not able to sustain manually creating CV entries and bug fixes and such. It's going just too fast, and there are not enough people to do that. And I would guess that quite soon there will be people who will start using AI to actually apply fixes, generate CV entries, and so on. AI automation. I think for some projects there's no other way right now. Whatever we think about it. We have time for one more. Yes?
It's a question or an observation that if someone is going to apply AI tools to fix those bugs, it might be easier to generate an observation tools to block potential attacks than to actually fix software. Because fixing software requires to check that you're not introducing new bugs. It's harder. It's easier if you can understand the pattern of the exploit and try to detect it, block it, like as an external service to the software.
The remark was that fixing an issue requires more work sometimes than actually blocking the attacks. So finding out that attacks happens, blocking the exploit basically from happening. My take to that will be that it depends. Yeah, and detection exploits is a field of its own. It's a whole big field on its own. Yeah. So, yeah, maybe for some cases.
You guys can start multiple startups.
The audience member saying people can start multiple startups, definitely. Okay, we are out of time. Thank you for coming to this session at the end of a very busy day. And I will be there during the whole conference, so we can chat later on. Thank you.